Hello and welcome back to another part of this video series. Today we have a look at numbers. So numbers are one of the basic things you learn in university math, so let's start into it. The set of natural numbers are defined as 1, 2, 3, and if you say that if you see the sign 0, this means natural numbers are as well 0. Cardinal numbers, how many elements are in a set, and ordinal number, this brings a certain order into a set. For example, we were 5 students, I'm the worst student. So the cardinal number would be 5, so 5 students, and I'm the worst student would give an ordinal number because it gives a certain order. The area of n, the set of all natural numbers, in the set of all natural numbers, multiplication, so this is the sign, and addition is always possible. Division and minus is not always possible. For example, 6 divided by 3 gives us 2, but 5 divided by 3 gives us an a, which is not part of the natural number. Same thing with 3 minus 5, this would give us minus 2, and minus 2 is not part of the natural number. So this sign right here means something is not an element of something. But multiplication and addition always works. This makes sense because let's think a multiplication is nothing else than you said 3 times 5, for example, is 15. So what you do is nothing else than 3 times the 5, 5 plus 5 plus 5. So you're just adding up 3 times the natural number, and this gives natural numbers. Same idea with the addition. You always get a natural number since there is no other possibility. To prove that a natural number will always give a natural number mathematically, this proof is actually quite interesting. Maybe I will cover that in another video, but this is a bit more complex than it seems. So we have the set of integers. So the set of integers is defined as set, it's correct, I think. Minus is on top always possible. Division is still not always possible. For example, 3 minus 5 would give us minus 3. So now our natural number set will be extended by minus 1, minus 2, and so on. As I said, division is still not possible because minus 2 divided by minus 1 divided by minus 2 gives us an a, which is not an element of the integers. So therefore we defined already 2 sets of numbers. The third set is the set of rational numbers. But before, let's cover this. Minus times minus a equals a, so plus a. Therefore minus a times minus a equals to plus a, and minus a times 1 gives us minus a. This proof is quite interesting, but it is also more complex than it seems, so I might cover it in another video. But always remember, this is true. So this number set of all rational numbers q is defined that you can write a equals to m divided with n, and m and z is an element of the integers. So both have to be, for example, 3 and 2, so integers. And n, of course, cannot be 0. Why do we say we can write things divided? This is extremely important if we try to define numbers. So since we already defined 1, 2, 3, we are thinking what is between. So since x has to be bigger than 1, but smaller than 2, we need something that is not 1 and not 2, and therefore, for example, this would be here, but it's like not in integers because it's smaller. This is like the space which is in between those numbers. So what is important for our rational numbers is that the number a, with the element of being in a set of the rational number, a is definitive or periodic. For example, 1/4, we see both are integers, is nothing else than 0.25. So this is not infinitive, and 1/3 equals to 0. Point period 333. So it's going yeah, so this is like 3, 3, 3, 3, 3, 3, and so on. Okay, so it's infinitive, but it's in an infinitive, but it's determined. So if you go like say, if you multiply this number by, let's say, 100,000, you will know that this will still look like this, because this just goes up there. But we will going to have a look deep on this. So I always said like that there's like this idea that between 2 and 3 is a gap. Okay, and the question is, between two numbers n, with n being a part of the rational numbers, with n being a part of the integers, how many others are there? So how many numbers, let's define this a bit better, a with the element q are there? So we're searching for how many rational numbers are between two integers 2 and 3. Give a concept proof for, so just explain what the concept is, or for experts give a math proof. We're going to have a look on this just in a sec. So pause the video and then come back. So for the concept proof, let's say we've got 5 and 6. So these are our two integers. We could say 5 plus 6 divided by 2 gives us something. So this gives us 11 divided by 2. And we know, if we just say this is nothing else than 5.5 divided by 2. So we know 5 plus 6 divided by 2 is between 5, so it's bigger than 5, but smaller than 6. So now is the question, are there still numbers? And yes, there are. So for a second number, let's just take this and let's say we add 5, and then let's make 11 divided by 2 and divide this by 2, and this is equal to 21 Thor. So we know this here is, if you just plug it in the calculator, let's do this real quick. So this is nothing else than 5, 2.5. So we know 5. So let's call this here a 1. So 11 is nothing else than this. We know, since this is 0.5, 5 a 1 and smaller than 6. Let's do this for n. So for n we would get, so let's say we've got n1 and n2 with that now comes to mathematical proof. I think the concept proof now is clear. We could just plug in 21 divided by 4 just again and do the same idea. So 5 plus 21 divided by 4 divided by divided by 2. Let's plug it in the calculator and what we get. Or how do we get a smaller number? Oh yeah, we get it. So it's 5.125. And what's interesting here, and we're going to have a look to this later, you will always get an integer. This is quite important. Not an irrational number, because there are irrational numbers. I'm sorry, I still get confused because in German we call it other numbers. So you still get a rational number. So the mathematical proof of this is, if you have n1 and n2 with, so that n2 minus n1 equals to 1, you can say n1 plus n2 gives us n divided by 2 gives you let's say c, and you know c has c is small is bigger than n1 and smaller than n2, and you could just add it, and you could do actually the sum and thing, but the mathematical proof behind this is just saying this is an infinite. So you could just do n1 plus, you just could do n1 plus c1, for example, divided by 2 and so on. So here you get it. So n1 plus n2 divided by c is equal to c, and n1 plus c divided by 2 equals to d, and n2 plus d divided by 2 gives us f, is an infinite operation, and that's complete the last part, which always will give us a number an a with the element of q, which is a n is bigger than n1 and smaller than n2. Although I would not do, let's say, x. Ax is better. Of course, you would have defined that n1 and n2 are both integers. So yeah. Okay, good. Let's go on. A number is an element of the rational numbers if if a is infinitive or periodic. For example, a divided by 4 is 0.25, and 1 divided by 3 is equal to 1.33333. So the period. In the rational number, in the set of the rational numbers, a, so the root, so getting the root of a is not always possible. So for 16 it is possible, since this gives us 4. For 4 it's possible, since it gives us 2, but 2 is not an element of the rational numbers. Those numbers are called irrational. So for example, p is equal to 3.14159 and so on. For calculating with irrational numbers, you are rounding. So you take, like, for example, for root 2, you take 1.41. Depending on how accurate your calculations needs to be, you use more decimal places. For example, let's see what the root of 2 is. This is like, if you say you want to extremely accurate, you take 1.414213562. So then your calculation gets very accurate. But of course, the more you take, the more accurate, of course, your calculating is going to be. This is like the principle of significance. So in physics, you often use just, like, for example, 2 decimal places, or 5, but depending on which field you're working in. We define a as an absolute value. So this here is a is the absolute value of a of a number a. Sorry, I'm getting confused. So what we're going to do is we're going to have a look at the distance from a number a to 0. For example, from -2 to 0, the distance is 2. From 2 to 0, the distance is 2. Therefore, the absolute value of -2 is, I'm sorry, my pen sometimes doesn't work, is 2, and the absolute value of 2 is 2. Because irrational numbers are extremely important, maybe I should add this, we're going to have a look at the proof of this in the next video. So after this video, I'm straight going to record another video about the proof of irrational numbers. So for every number c, which is defined as the absolute value of a, c is going to be bigger or equal to 0. So this means, for example, if you have -2, then you get 2. And 2 is bigger than 0, of course. The sets of the natural numbers, the integers, the natural numbers, the integers, the rational numbers, and the irrational numbers are called the set of the numbers the set of the numbers of all real numbers. So following relations between those sets. So for example, natural numbers. I'm so sorry. Natural numbers are a subset of integers. Yeah, the subset is the integers are a subset of the rational numbers, and the rational numbers are a subset of the real numbers, and the irrational numbers are a subset of the real numbers. Therefore, but as I said in the last video about set theory, we don't need like to write this. The natural numbers are a subset of the real number, the natural numbers. I'm so sorry, I don't know what's going on. So let's have a look again on the rational numbers. We already said A is defined as P is an integer set, an integer divided by an integer. So let's say you should write A equals to 1, A equals to 0.1 period through 6. So the idea of what we're going to do is we multiply this number by 1,000. It should be 1,000, right? Yeah, by 1,000. So you know, if you, for example, say you have this, and you multiply this by 1,000, you will see, if you put this in the calculator, what's going to happen. Wow, you get 3333.3. Why? So this times 1,000. So this gets there, this gets there. So, and then you get like 3.3. So the thing what's going to happen is you just move like the point. So this is like the thing in German schools, they say you're moving the point. Yeah, like for here. So for every 0, I'm sorry, I forget this one. For every 0 here, you just move the, yeah, a bit better. Yeah, this is like the concept. Therefore, 1000A equals to this, so 126 point period of 26, and then you just have a look to 10A, because you want to have this. This is like the thing you don't want to have. So what are you going to do is you are going to divide this here by, let's see, 100, because you want to just have then it's going to move back, if you understand what I mean. And this gives us a period, since 26 is like periodic. Therefore, if you get like 12626, this is equal to this. So then we're going to subtract 10A, because we don't want to have the period here, because if we try to do this in the form here where we want to have integers, we can't have this, because you see this divided by something doesn't work. So we just subtract this from here. We get 990A equals to 125, because we just subtract this, and we know this is going to leave us, so we just have 126 minus 1, and this gives us 125. Then we just divide by 990, and we get 125 divided by 990 equals to 25, to 125 divided by 990. And if we know 5, if we now divide both things by 5, we get 25 divided by 198, and this is equal to this. So you see, you can write every rational number in this form. Of course, if you have an irrational number, this won't work, because to do something like this, multiply this by 1000, you need to know, like, there has to be a rule, because then still you would like have numbers after the decimal. So this operation, so this step here wouldn't work. You understand what I mean? You would still have decimal. You would still have decimal places, I think is correct. Exercise. So this is like something I just wrote random, some number which came to my mind. Write this as P divided by Q. Just try this and come back. Just pause the video. So the solution to this is quite easy. Same idea. You multiply this with 1000. So what you will get is this here. You make minus 10a, you get 42 with the period of 36. So then what you get is 990a, then equals to 4,194, and then you just divide by 990, you get 4,194 divided by 990, divide this by 18, so you get 233 divided by 505, and this is equal to 4.2 and period of 36. Yeah, very nice. So this is like the whole thing you need to know about sets, of number sets for the beginning. Let's get to the exercise. The sum and the product of two numbers in the number range are again part of this number range. A is just say all are the irrational numbers in number range after this definition. So 2, so let's see, for example, 2 times 2 gives us 4, and 2 plus 2 gives us 4 as well. So the sum of the product gives us then another rational number. It gives us another natural number in this case. The same thing, for example, you can say with integers. If you make minus 4 times minus 2, this gives us 8, and 8 is part of the integers. So this states truth. So the question is if this applies on irrational numbers as well. Pause the video, try to solve this. Concept proofs. By the way, mathematical proofs mean if you find only one example which does not fit this rule, then you show that this is wrong, and then you need like a big proof for general. Yeah. So pause the video. So the root of 2 is an example that this is wrong. So we know the root of 2 is irrational, and since the root of 2 times the root of 2 gives us 2, 2 is equals to 2, we get a non-irrational number. Therefore, this states true, because yeah, the root of 2 times the root of 2 gives us 2, and 2 is a natural number, and the natural number is not an irrational number, therefore this is wrong. So, give a number that is between 17 divided by 23 and 18 divided by, and 18 divided by 23. Pause the video, just do this real quick. So, where is it? I thought I actually wrote it down. So what you can do here, for example, number is, yeah, this should be right. Yeah, it should be. Yeah, exactly. So, for example, what I mostly do is just like make here +1, and then add here +1, and often there are like between. But you can like do some things like, yeah, I don't know, try to make it bigger and so on. So you could multiply this by 4, and then you get other numbers, or there's like this kind of idea. Yeah, but in this case, 18/24 is correct. Yeah, so give a proof why a times 0 equals to 0. This is actually kind of, yeah, this is actually difficult, so try this. The concept proof of this is quite easy. Let's say you have 2 apples, and you want to know how often 0 apples fit in those 2 apples. You know, okay, you have 0 apples, so it fits 0 times in it. Mathematically, and this is actually quite difficult. So a times 0 is equal to a plus 0. This is equal to a times 0 plus a minus a, which is then equal to a times 0 plus a plus minus a, which means this is nothing else than a times 0 plus a times 1, right, plus minus 1, minus a. So you now could like factorize this. This gives us a times 0 plus 1 plus minus a, and a times 1 plus minus a gives us a plus minus a. So you got rid of the 0, and this is equal to 0. So this is actually quite difficult, but yeah, if you figure it out, it's extremely good. So yeah, just that you've seen this one time. So this was the video. Thank you very much for watching it, and see you guys very soon in the next video, to be precise, hopefully.